So again, with the lecture recordings, the previous year's recordings are available. So in the playlist, it will say 2023, 2024, 2025. So you can go back to previous years if you want to go ahead in the work. But I suggest, keeping track with the current year's work. Okay, things do change from year to year. Okay, but if you've got any questions on that, just send me an email. I can help you out. Okay, so for this week, we're going to do a very quick summary over the algebra that you need to know. So for a lot of you, you would have covered this in matric. That's fine. We're going to do a recap of it so that everyone's on the same page when we start functions. Okay. So algebra. Okay, you will also see this as pre-calculus if you are looking in the textbook or online. Okay, so the main calculus stuff, that will start a bit later when we look at functions and derivatives and so on. But for now, we're looking at pre-calculus. This will be tested. Okay, so even though it is a summary of work from previous years, it can be tested in class test 1. Okay. Okay, so the stuff we're going to be covering are integer exponents, okay, rational exponents, okay, radicals, okay, polynomials, factoring polynomials. There will be a lot of factoring coming up. So if you are unfamiliar with factoring cubics and quadratics and so on, please make sure you're paying attention for that part. Okay, 6 rational expressions. Okay, 7 linear inequalities. 8 polynomial inequalities. 9 rational inequalities. 10 absolute value equations. And 11 absolute value inequalities. Okay, this is not just work to waste time. This will be all of the skills you need for us to start with the differential calculus. Okay, so when we get to calculus, I expect that you know all of this and that we can just start with functions and so on. Okay, this will not be retaught when we're doing questions later on. So when we get to functions and in the working for some problem, if you need to factor a cubic polynomial, I will expect that you already know how to do that. Okay, so I'm not going to reteach this every time it comes up in a problem. Okay, so for this week, we'll go through all of this, and then after that, I expect that you know all of it. Okay, along with all of the work we're doing in the lecture, there is a tutorial on this. Again, look at your Learn 2025 page. You'll see the tutorial there. The solutions will be posted next week. Okay, so for this week, that first tutorial, please try to go through that. Okay, again, no one's going to check your tutorial work. Whether you do it, whether you don't do it, that's up to you. Okay, Again, whether you pass or fail, that's also up to you. Okay, so first thing, integer exponents. We'll go through it as if you never saw it before, but we will be going through it quite quickly. Okay, at any point, if you're lost, you want me to slow down or explain something, just put your hand up or yell out and I will stop for you. Okay, but if you're all quiet, we just move on through it. Okay, so integer exponents. This is also question 1 for the quiz next week. Okay, we'll be on integer exponents. Okay, if A is any number, and n is a positive integer, okay, then we write a superscript n, so a to the power n. What does this mean? This is just a times a times a times a, n times. Right, everyone should know that, but we'll just go through it as revision. Okay, for example, if we have 3 to the 4, this is just 3 times 3 times 3, that's 3 of them. We need one more, that's 3 to the 4. Okay, I expect everyone to know that. Okay, properties. Okay, so when given some expression with exponents, we will be using these properties to simplify what's given. This will be used a lot later on. So in the course of doing a calculation, you might end up with some big mess with exponents everywhere. We want to try to simplify that as much as possible. Okay, to do that, we use these 8 properties. Okay, number 1, a to the power n times a to the power m. Okay, we got the same bases, we got different exponents, we add the exponents. So a to the n plus m. Okay, number 2, if we have a to the n and then to the m, okay, so in brackets we've got some exponents expression, and then all of that is raised to the power m. The m gets distributed inside using multiplication. So this will be a to the n times m. Okay, number 3, similar to number 1. So number 1, we're taking the product. For number 3, we're going to take the quotient. So a to the n divided by a to the m. This now becomes a to the n minus m. So product goes with addition of the exponents. Division goes with difference of the quotient of the exponents. Okay, number 4. If we have a b to the n, so the product inside, the exponent outside, that just distributes onto each factor. So that will be a to the n times b to the n. Okay, easy stuff. Okay, number 5. So similar to number 4. Number 4, we took the product. For number 5, we can take the quotient. So a divided by b to the n. Again, it just distributes onto each one. So that will be a to the n over b to the n. Okay, very similar to what we have in number 4. Okay, number 6. So if we have 1 over a to the n, so we're taking the reciprocal of an exponential term. The n in the top there becomes minus n. So this will be a to the minus n. So remember back here with the definition, this a to the n works for positive integers. We can write it like that. This allows us to write it with negative integers. So if you have 3 to the minus 2, right, that's just 1 over 3 squared. That's how you can work it out. Okay, 7. If we have a to the 0, this is going to be 1. Cool. But here, a cannot be 0. So 0 to the power 0, that's undefined. Okay, you can't do that. So if a is anything else besides 0, then we have this. So on the side, we just write a is non-zero. Okay, and then similarly for 8, if we have 0 to the n, so 0 to the power of something, remember the definition here, it's just 0 times 0 times 0 times 0. Well, that doesn't matter, it's still 0. Okay, but we do need to be a bit careful. We can't have 0 to the power 0. So here, n cannot be 0. So in these two cases, we want to avoid 0 to the 0, which is undefined. Okay, but besides that case, those two properties hold. Okay, we'll go through a few examples, and then the rest I will leave you for the tutorial. Okay, again, if you're stuck with anything as we're going through it, just put your hand up or yell out or something so that I can see you. Then we'll stop and I'll go through it again. If everyone's quiet, we just move through at this pace. Okay, but the pace, that's determined by you. You tell me to slow down, I'll slow down. You tell me to speed up, I'll speed up. Okay, so number 1, we have 4x to the minus 4, y to the 5 cubed. Okay, so imagine we get this at some stage in our calculation. It's a bit of a mess right now. We want to simplify. So instead of looking at this as it is like that, we go through the properties listed here, okay, 1 to 8, and we try use those properties to simplify. So first, I can see there's some products going on in the brackets raised to some power. So if we look back here, that looks like number 4. So we're going to be using that. Also, I can see there's a x to the minus 4. Okay, negative exponents. How do we deal with that? We go back here. That's number 6. Okay, so individually, we can see what's going on. Let's put it all together. Okay, so the first thing I'm going to do is put the x at the bottom, okay, because of the negative exponents. So that's going to be 4y to the 5 over x to the 4 cubed. Okay, so negative exponents, those are all gone. Lastly, the 3 on the outside, we can distribute inside, and we can use number 5 for that. We can just distribute it. Okay, so we end up with 4 cubed. Okay, you can simplify that. Just a note on that, you are allowed your calculators. Okay, please feel free to use your calculators when simplifying. Okay. Other modules I cannot say. Please check with your lecturers about that. For MATH160, 161, you're allowed your calculators. That's fine with me. Okay, but please do check for the other modules. Okay, y to the 5 to the 3. So 5 times 3, that'll be 15. Okay, x to the 4 to the 3. So 4 times 3 will be 12. Okay, you can leave it like that. That's perfectly fine. 4 to the 3, if you want to simplify that, you can. I'm not too worried with that. Okay, number 2. We've got minus 10z squared, y to the minus 4 squared, z cubed, y to the minus 5. Okay, again, before we rush into things, let's see what we're working with. In the first bracket, we've got a product of things, and we've got y to the negative exponent. We know how to work with that. Okay, second bracket, not too much going on there, but notice, again, we've got a negative exponent. We need to deal with that. So let's do that first. So in the first case, we're going to have minus 10z squared over y to the 4. Okay, so all the negative exponents have been dealt with, and then all of that squared. Okay, in the next bracket, there's no negative exponents in the bracket, so that's all fine. But it's to the minus 5. So this is going to be 1 over z cubed y to the 5. Okay, and then we can just distribute like we did before. So minus 10 squared. If you ever forget what to do, remember squaring is just timesing by itself. So minus 10 times minus 10, that's 100. Yeah. Okay, the minus goes away when you square it. So we've got z squared again, 2 times 2, that will be 4, so z to the 4. Okay, y to the 4 squared, 4 times 2, that will be 8. Okay, and then for the next one, z cubed to the 5, 5 times 3, that will be 15 in the bottom. Okay, and then y to the 1, there's a 1 there, to the 5, so that's just y to the 5. Okay, so 100 z to the 4 over y to the 8, z to the 15, y to the 5. Just putting that all together. Now we've got some common variables there. We've got z at the top, z at the bottom. We can simplify that. And in the bottom, we've got y to the 8 and y to the 5. We can simplify that. So this will be 100. We've got z to the 4 at the top, z to the 15 at the bottom. The bottom one is larger, okay, 15 at the bottom. So we're going to have some positive exponents in the bottom. And that will be 15 minus 4 in the bottom. That'll just be 11 left over there. Does everyone see what I did there? Great. Okay, if this is boring to you, please just go with it. Next week, we're going to get into university work. You're going to wish we were doing this still. Okay, so just go with it for now. Okay, y to the 8, y to the 5. We're going to add the exponents. What do we get? 13. Everyone agree? Cool. Okay. Easy stuff. Next few I'll leave for homework. You can try it out. I think everyone gets the idea. Okay, just a note on the difference between homework and tutorials. Tutorials are work that you do throughout the week. Okay, you'll get your solutions for that. Homework, that is just stuff that I give you during the lecture. I will post the solutions after the lecture. Okay, so you try it out at home and then you have a look. Okay, so it's just smaller amounts of work that you can do per day. Okay, non-compulsory, no one's going to check on you, but rather do it. Also, a lot of the quiz questions and the test questions come from the homework. Just as a little hint. Okay, so homework number 1, we've got n to the minus 2, m over 7m to the minus 4, n to the minus 3. Okay, again, we've seen all of this already. You know what to do. Okay, number 2, we've got 5x to the minus 1, y to the minus 4, over 3y to the 5, to the minus 2, x to the 9. Okay, last one just to try. We've got, z to the minus 5, over z to the minus 2, x to the minus 1 to the 6. Okay, so it's got pretty much all of the properties that you need to know. Okay, again with the homework, no one's checking your homework. That's up to you. You're all grown up now. You don't need someone watching you. The solutions will be posted at the end of the lecture, so when this is uploaded later today. But please try it out before looking at the solutions. Okay. Looking at the solutions, you might think, oh, this is obvious, I know what to do. Then you come to the test and you realize, I have no idea what to do. Okay, so struggle a bit to figure it out on your own, then look at the solutions afterwards. Right, any questions on this exponent work? All good. Okay. Next, the binomial expansion. Okay, so if we go back to the properties over here, number 4. So we looked at the product of two things to some exponent. We looked at the quotient of two things to some exponent. But what about the sum of two things? Okay, that's not under the properties here. That is under the binomial expansion. There's a whole theorem that goes with it. We're not going to go through all of that. We're just going to see what the result is. So if I have a plus b to some power n. Again, n is some positive integer. So a plus b to the 1, a plus b squared, cubed to the 4, and so on. Okay, so let's just go through some cases. So a plus b to the 0, we know what that is. Anything to the power 0 is 1. Easy stuff. Okay, a plus b to the 1. Anything to the power 1 is just whatever that was. So that's just a plus b. Okay, a plus b squared. A lot of students mess this up. Okay, but this is going to be a squared plus 2ab plus b squared. Please do not write a squared plus b squared. Okay, don't do that. Okay, in the class test, say question 3, you need to have a plus b squared. If you give me a squared plus b squared, I'm going to ignore the question and mark the other stuff. Okay, I do not want to see that. I'm not marking your question if you write that. Okay, everyone clear? Okay. A plus b cubed, you can expand that out. But what we're looking for is a plus b to the n, where n can be whatever integer. So this is given by the sum from k equals 0 to n. Okay, you're familiar with sigma notation? Awesome. So k equals 0, not from 1, from 0. Please keep that in mind. Up to n, where that n is the same as the exponent. So please, we start from 0, we do not start from 1. Okay, then we have n choose k. I'll go through that in a bit. We have a to the k, where that's the first term, a to the power k. K is the index of the summation. Times b, that is the second term, and the exponent is whatever's left over between k and n. So that will be n minus k. Okay, so easy way to remember this. If we have, let's say n is 3, when k is 0, b is whatever's left over. So that's 3. If we have a to the 1, b is whatever's left over. That's 2. 1 plus 2 is 3. If a is to the power 2, b is whatever's left over. That's 1. 2 plus 1 is 3. If k is 3, b is to the power whatever's left over. That will be 0. It always goes like that. So let's say for 4, it will be 4 and 0, 3 and 1, 2 and 2, and so on. Okay, you get the pattern. Okay, n choose k, you would have seen that in matric, but we'll go through it again. This notation of n at the top and k at the bottom, this is just a short way of writing n factorial over k factorial. So n at the top, k at the bottom, k at the bottom. Okay, so that's how you know what goes where. And then there's a little extra at the bottom. That will be n minus k factorial. So we read this as n choose k. Okay, now you could use your calculator to find what these are. That's a waste of time. Please do not do that. You're just wasting time you could have spent on something else. Instead, what we use is something called Pascal's triangle. Has anyone heard of that? There were some yes, some no. Let's go through it. Okay, Pascal's triangle. Okay, if there's anything that I encourage you to remember from this lecture, is Pascal's triangle. Okay, so it is a triangle, hence the name, and it allows us to calculate these n choose k terms very easily. So instead of you sitting on your calculator going 3 choose 1, 3 choose 2, You just write out the triangle, couple seconds, you've got your answer. So the way it's set up is right at the top, we have 0, choose 0. Okay. And then what we do is we build up this triangle or pyramid row by row. So the next row will be 1, choose 0, 1, choose 1. Okay. So in the top of the n choose k, that is on what level we're on. So right at the top, there's the 0, that is the 0 level. Next one, we've got 1, so n is 1. And then going left to right, the k increases from 0. So we've got 0 and 1. You can guess what the next one will be. Now we're on the second level, okay, starting from 0, 0, 1, 2. And left to right, we go through k. So it's going to be 2, choose 0, 2, choose 1, 2, choose 2. Yeah, sure. Yeah, that's fine.
Okay, so tomorrow, on your timetable, you're supposed to have a physics lab at 8:40. Okay, so they called me at the lab. They want you to come and collect the lab manuals. So maybe what's best to do, because you don't know where the lab is, you can come at, let's meet at 9 here in the Unite building tomorrow. And then I'll ask someone to take you to the lab. Is that fine? Okay, all right. Okay.
Sure. Okay, so we build up the triangle in this way. Again, n, that's the row we're working on, and then k, that goes left to right in the bottom there. So let's look at the next row. You'll tell me the answer. What goes in the top? 3. 3, choose 0. Then? Nice. And then? Awesome. Okay, you're all experts already. Okay, so again, going down, that is going to be n. Left to right, going across, that will be k. So going down, this is n. Going across, that is k. And then you can pick out the coefficients that you need. So over here, for each n choose k that you want to work out, we draw up this triangle, and then you can see where it is. Okay, so this is the setup of the triangle. How do we find it in practice? So instead of doing all of these manually, there's a rule on how to get from top to bottom. Okay, so in the top, 0, choose 0, that is 1. And what we do is, as we go to the next row, we put a 1 on either side of the triangle. So the next row will be 1 and 1. Okay. Then the next row, we put 1s on either side again. So 1 and 1. Now there's something missing here. That will be the 2, choose 1. The way we found it is we look to the previous row and add those 2. So we have 1 and 1 in the previous. We add those together, we get 2. So there and there we add up, we get 2. Let's do the next one. We're going to have 1 and 1. And we need to fill in the missing bits. Again, we look at the previous row, add them up, and we get that value. So we've got this value missing and this value missing. That corresponds to this and this. So we're going to take from the previous row, the 1 and the 2. We add that up, we get 3. So there and there, we get 3. And for the next one, we do the same thing. We've got 2 and 1, we get 3. And we carry on like that. So for the next row, that will be 4, choose k. We do the same thing. So we're going to have a 1 starting. Then the next number will be 1 plus 3. Then the next number will be 3 plus 3. Then the next number will be 3 plus 1. And then the last number will be 1. So we're going to have 1, 3 and 1, that's 4. 3 and 3, that's 6. 3 and 1, that's 4. And then the 1. Okay, everyone okay with this? Okay. Now, like I said, as we go through top to bottom, that gives us the coefficients in the binomial expansion. That gives you these guys over here. So let's just go through it. The first one is 1. That is when n is 0. Let's check back here. So a plus b to the 0, 1. Okay, that works out. Next one, a plus b to the 1. That's this row here, 1 and 1. Let's go here. Yep. 1 times a plus 1 times b. That works out fine. Next one, a plus b squared. So we're looking at this row here, the 1, 2, 1. It's going to be 1, 2, 1. Let's check that. So that will be, yep, 1, 2, 1. So 1, 2, and 1. Okay. Much easier than using your calculator to work out each one individually. So now that we've got this row here, this was for number 4. Let's have a look. So let's say we wanted a plus b to the 4. So all we do is we draw this triangle from 0. Remember, we always start from 0 down to 4. So this one is for 0. This is for 1. This is for 2. This is for 3. This is for 4. And we don't go past that because we're only interested in 4. So we go through the pattern. First number is 1. So we put a 1. Then it will be a to the power 4. Because remember, we go back here. Okay, it doesn't matter the order, just start from 4. Okay, or you can start from 0. But you'll see you get all the terms in the end. So we'll have a to the 4, b to the 0. Because the exponents must add up to 4. Because that's what we're working with. Plus. The next coefficient is 4. So it will be plus 4. Now it will be a cubed b to the 1. Again, the exponents must add up to 4. Like we had over here. Over there. They must add up to n. Okay, next one. That's a 6. So that will be a squared b squared. Again, they must add up to 4. Next, that is a 4. So we put a 4. Then it will be a1b cubed. Again, they must add up to 4. And lastly, we get the 1. So that will be a 1. A to the 0, b to the 4. Okay, as you do more practice with this, the b to the 0 you can leave out. That's just going to be a 1. So you can leave that out there. B to the 1, again, with practice, you're just going to write b. You're not going to write b to the 1. And over here, a to the 0, you're not going to write a to the 0. You're just going to leave that out. Okay, but, for the first few, write it out explicitly like this. Okay, and then you'll end up with a to the 4, 4a cubed b. I'm not going to put the 1. It's not needed. Plus 6a squared b squared. Plus 4ab cubed. I'm not going to put the 1. It's not needed. Plus b to the 4. Again, I'm not putting the 1 or the a to the 0. It's not needed. Okay. But for the first few, please write it out fully like this first line. As you get more confident with it, you can then skip all of those unnecessary details. Okay. Any questions on the binomial expansion? All good. Okay, next thing. Okay, rational exponents and radicals. Okay, so far we've been working with integer exponents. So a squared, b cubed, z to the 4, so on. What happens if we have a rational exponent? Just a reminder, what is a rational number? Some integer divided by some other integer. So we end up with a to the m over n. So some integer m, some integer n, that makes a rational number. How do we work with this? Well, this just means we're going to have a to the m. So the numerator goes there. That's going to be our power to the power 1 over n. So we can split it up like this. Again, just go backwards. We'll see we end up with that. So a to the m to the 1 over n, we multiply. So m times 1 over n, that's just m over n. That's what we started with. Okay, easy stuff. But we could also do this the other way around. We could swap the exponents. There we get the same thing. So that will be a to the 1 over n to the m. Again, you take the product, you get the same answer, so the order doesn't matter there. Okay, what is this a to the 1 over n? We call that the nth root. So a to the 1 over n is called the nth root. Okay, so if we have a to the half, that is the square root. Okay, you're all familiar with that. A to the 1 over 3, that's the cube root, fourth root, fifth root, and so on. Okay, nth root. So a to the half, that is the square root, right? Just root a, you know what that is. So square root. Okay, a to the 1 over 3, that is the cube root. I would prefer you to write a to the 1 over 3. Okay, small reason. Cube roots of a can very easily become 3 root a. Okay, if you are rushing in a test and you are trying to write 3 root a, the 3 after many lines of working can end up going down and becoming 3 root a, and now you got it wrong. Okay. However, if you have a to the 1 over 3, you can't really mess that up. Okay. So just a little note there. You know, mistakes can happen while you're stressed and so on. So I would avoid square roots is fine, right? You can keep with that. But anything higher, please do not put the 3 in front there. Okay. Mistakes will be made, I'm telling you now. When you're rushing and so on, I do see that. The 3 ends up becoming in front. I can't tell what you're doing. I mark it wrong. Okay. And so on, right? A to the 1 over 4, fourth root, fifth root, and so on. Another word for this is radical. So you could call it roots, you could call it radicals, same names, different names, same thing. Okay, you can use whatever wording you like. So radical or root means the same thing. If you're looking in the textbook, I think the Stewart calls it roots. At some point, they do switch over to using the word radical, but it's the same thing. So the nth root of a is just a to the 1 over n. Okay, again, same thing. Okay, properties. Okay, very similar to the properties we had with integer exponents, so I'll just write them out quickly. So number 1, if we have the nth root of a to the n, that is just a. Okay, quite obvious, because this is just another way of writing a to the n over n. N over n is just 1. A to the 1 is a. So easy there. Okay, number 2. Nth root of AB. This is the nth root of A, nth root of B. Okay, but remember A and B must be positive. Okay, so specifically for square roots, you can't take the roots of a negative, so problems happen there. Okay, and then number 3, we've got the nth root of a quotient. Okay, very similar to what we had before. It just becomes the root of the numerator and denominator. So nth root A, nth root B. Okay, and then just another warning on this. So remember the warning of A plus B, all of that squared, is not A squared plus B squared. We have a similar thing in this case. Root of A plus B is certainly not root A plus root B. Again, if I see this in your working, I'm going to skip and carry on marking from there. Okay, you make these mistakes in the test, I'm just skipping it. Okay, you cannot be in university making these mistakes. Okay, so this goes together with the a plus b squared is not a squared plus b squared. Okay, similar mistakes there. Any questions on the properties? All good? Okay, rationalizing the denominator. Sorry, this pen. Have you all heard of rationalizing the denominator? You should have covered it in matric. Okay, we'll just go through a few examples just to refresh your memory. Okay, rationalizing the denominator. Okay, much like the other properties, this is just to use to simplify your expressions. Okay, so it's not needed 100% of the time, but if you do need to simplify things, this is one of the tools that you can use. Okay, number one, very easy example, 4 over root x. Okay, when we say rationalize, a better word would be non-radicalize, I know, something like that. The aim of the game is to remove the roots from the denominator. So here we've got root x in the denominator, we want it to go away. Remember that root x is x to the half. If we have x to the half times x to the half, that's x to the 1. Now the half is gone, so it's no longer a radical. And that's what we're going to do. We're going to multiply the bottom by root x. We can't just do that to the bottom, we have to do it to the top. So we multiply by root x over root x. Altogether, that's just 1. We haven't done anything. Okay, but in the top, we now have 4 root x. In the bottom, like we said, half plus a half is 1. So we just get x. Okay, so no more radical in the denominator. Okay, number 2, we got the fifth root of 2 over x cubed. So the fifth root of a quotient, we can do that to the top and the bottom. So we end up with the fifth root of 2 over the fifth root of x cubed. Okay, we got a radical in the denominator. We got the root, we want to get rid of it. What is that? The x cubed fifth root. So let's do a little bit of side working here. So what is that? That is x to the 3 over 5. The 3 comes from the fact that it's x cubed. The 1 over 5 comes from it being fifth root. Now we're going to do something similar to number 1. In number 1, we had x to the half. So we multiplied by x to the half so that the sum would be 1. Here we've got x to the 3 over 5. We need to multiply by something to get rid of the fraction. So 3 over 5 plus what is 1? What was that? 5 over 3. No, we're adding, not multiplying. Someone said it on the side? 2 over 5, yeah. Okay, because the 3 and the 2, that makes a 5. We end up with just x, like we wanted in the first problem there. So that's what we do. So we're going to have the fifth root of 2 times the thing we needed to get to 1, that was x to the 2 over 5. Over, I'll write it with the rational exponent. So that was 3 over 5 times x to the 2 over 5. Okay, what do we get at the top? We can write it as a radical again. X to the 2 over 5. The 2 means it's x squared. The 1 over 5 means it's the fifth root. So this is the fifth root of 2x squared. And then the 3 over 5 and the 2 over 5, that just makes 1. So we just get a x. Okay, no more roots in the denominator. That's exactly what we wanted. Any questions on this one? Yes? No, if there's plus or minus, it works exactly the same. Yeah. So whatever plus minus, we're not interested in that. It's only that these exponents add to 1. So here, this was 3 over 5 plus 2 over 5. That's 5 over 5, which is 1. That's all we want. There was another question? Yes? Yeah. Yeah, no, we don't want to swap it because we're adding the fractions. The denominators must be the same. So if we have a over b and we're adding it to c over b, that's a plus c over b. The denominators must stay the same throughout. Okay. Yeah, so just a little note there. So that's from there. Okay, we want to keep the denominators the same. Any other questions? All good. Okay. Number 3. Okay, 3 is a little bit different. So here we have 1 over 3 minus root x. Okay, so in the previous cases, we just had the radical just by itself. Now we've got 3 minus some radical. Okay, how do we deal with this? Well, we use what is called the radical conjugate. Okay, scary sounding name. It's not at all. What this just means is it's the two factors when we look at the difference of squares. So imagine we had a squared minus b squared. Right, you know your dots, difference of two squares. This we can factor as a plus b, a minus b. We call these conjugates. So one of them comes with the plus, the other comes with the minus. Or if you have the one with the minus, the other comes with the plus. That's what we mean by conjugates. So in this case, the 3 minus root x, what we're looking at is 3 squared minus root x squared. Okay, that's like your a and b from there. This would be written as 3 plus root x, 3 minus root x, just like we had before with the a and the b. Then on the right, 3 minus root x, that's what we're given. The conjugate is just the other term. That will be the 3 plus. Okay, that's all that the conjugate is. It's just the other factor in the difference of two squares. Okay, I don't know why they give it a name like that, but that's what we have. So here we've got 3 minus root x. We want to end up getting a difference of squares. So what do we need? 3 plus. So that's what we multiply by. So we have 1 over 3 minus root x times by the conjugate. Now we can't just multiply the denominator by the conjugate. It needs to be conjugate divided by conjugate. So 3 plus root x, 3 plus root x. Because together that's just 1. Now we'll see what happens in the denominator. We're going to have 3 plus root x over 3 minus root x, 3 plus root x. And that's exactly what I meant on that right-hand side. What we did was we built up the right-hand side of the difference of squares. That's all we're trying to do. Okay. So from the single conjugate bit, we multiplied by the other half so that we end up with a difference of squares. And now that we have a difference of squares, we can just write down the answer. This is a difference of squares with 9 and x. Just expanding the squaring. So 3 squared, that's 9. Root x squared, that's x. And again, no more rational exponents in the denominator. Okay, last one for homework. So we have 5 over 4 root x plus root 3. Okay, again, we've got some radicals in the denominator. We want to get rid of them. We need to find the conjugate. So this is the conjugate part that comes with the plus. The other one is exactly the same, but with the minus. You don't even need to think about it. If that's a plus, you multiply by the one with the minus. Okay, you can simplify that for homework. I think we finish at 2, I think it is. Okay, making good time. Any questions on rationalizing the denominator? All good. Okay, again, please keep in mind, I'm not reteaching this when we get to the other work. So later on, when we do differential calculus, if this comes up in the working, I expect you to know this. Okay, I'm not going to reteach it for each question. Okay, again, any questions? All good. Okay. Next thing, polynomials. Okay, we're not going to spend too much time on polynomials. Everyone should know what that is. Okay, but quick summary. An nth order polynomial is given by a to the 0, that's just some number, a1 x to the 1. Okay, again, x to the 1, that's just x. A2 x squared plus dot dot dots plus a n x to the n. So each term there with some exponents has some coefficients. So the x to the 0, that's just a0. X to the 1, that comes with a1. X cubed, that will come with a3, and so on. Okay, that's a polynomial. So x is the variable. Okay. A0 to an are the coefficients. Okay, it's just the names given to these things are the coefficients. Okay. And then whatever the highest exponent is, we call that the degree or the order. So the degree slash order, same thing, of the polynomial is the largest exponent. Okay, a little note after simplifying. You do all of your simplifying and then you see what the largest exponent is. Okay, I think that's pretty standard. Everyone should know that. Okay, polynomials in more than one variable. Maybe you haven't covered this. Okay, so it's the usual polynomial like we have here. Some coefficient, some variable to some power, but instead of just having x, we now have xy, xyz, some number of variables. So let's say polynomials in 2 variables. So just as an example, polynomials in 2 variables will contain something like ax to the m, y to the n. So it'll be some sum of these. So some coefficients, x to the m, okay, x squared, x cubed, so on. Y to the n could be the same, could be different. So y to the 1, 3, 5, whatever you want there. Okay, the degree of this polynomial is the largest sum of m plus n. Okay, so in the previous case, we just looked at the largest exponent of x because there is only x, so we look at that. In this case, If there are two variables, we look for the largest sum of m plus n. If there were more variables, you look at the sum of the 3. If there's 4 variables, you look at the sum of 4. Okay, easy stuff. Let's have a look at some examples. Okay, we've got x squared y minus 6x cubed y to the 12 plus 10x squared minus 7y plus 1. Okay, we want to find the degree. Now, this is in two variables, so we need to look at the sum of the exponents. Okay, first term, x squared, y to the 1. There's a 1 there. That sum is 3. So just keep in mind, that one's 3. Next one. Forget the 6, we're not interested. We're only interested in the exponents. X cubed, y to the 12, the sum is 15. That's bigger than 3, so let's keep 15 in mind. Next one is x squared. There's an invisible y to the 0 there. Remember, two variables. If the variable is missing, it's to the power 0. So we've got 2 plus 0, that's 2. 15 is still bigger, so we keep track of 15. Next, 7y to the 1. X is missing, so that is x to the 0. 1 plus 0, that's 1. 15 is still bigger, so we carry on. Next is 1. X and y are missing, so that must be x to the 0, y to the 0. The sum is 0. 15 is still bigger, so the degree is 15. Okay, easy stuff. You just go through term by term, and you look for the largest sum. Okay, next example, 6x to the 4 plus 8y to the 4 minus x y squared. Okay, let's go through it. The first term is just x, but we see that the other terms contain a y, so it's a polynomial in two variables. The first term doesn't tell us anything. The other terms tell us that there are x and y. There's just an x, so we can put a y to the 0 if you want. Okay, 4 plus 0, that's 4. That's the largest so far, so let's keep that in mind. Next one is y to the 4. X is missing, so that's a x to the 0. That's also 4. 4 is not bigger than 4, so we still keep track of 4. Next term, that is a x to the 1. So that's 3. 4 is still bigger, so it's degree 4. Okay, again, it's whichever is largest. If two terms have the same degree, doesn't matter, it's just whatever's the largest. Next, x to the 4 y squared minus x cubed y cubed minus xy plus x to the 4. Okay, let's go through it again. X to the 4 y squared, the sum is 6, so we keep 6. Next, x cubed y cubed, the sum is 6, not bigger, so we keep 6. Next one, that's x to the 1 y to the 1, the sum is 2. 6 is still bigger, so we keep 6. Last one, x to the 4, y to the 0, the sum is 4. 6 is still bigger, the degree is 6. Okay, easy so far? Okay. Next one, 6x to the 14 minus 10y cubed plus 3x minus 11y. Okay. First term is x just by itself, but if we look at the other terms, we see that there's y's as well. So it's a polynomial in two variables. Looking at the first term alone and the second term alone doesn't tell you anything. The whole thing contains x and y. It's a polynomial in two variables. Okay, we'll do this one a bit quicker. First one is 14, then 3, then 1, then 1. 14 is the biggest, degree 14. Okay. Any questions so far? Okay, easy stuff. We're just taking sums, keeping track of the highest. That's the degree. If we had x, y, z, then you would just be summing up the 3 exponents. So whatever number of variables you have, we do it in the same way. Okay. Any questions before we move on? Everyone good? Okay. Next, factoring polynomials. Okay. Factoring polynomials, you'll be using this throughout the next 4 years of your degree. Okay, so you did factoring polynomials in matric. It does not go away. Okay, you will see it all the way to honors engineering. Okay, or it does not go away. Okay, so what do we want to do with factoring a polynomial? So consider the product. Okay, we're going to have x plus b1, x plus b2, x plus b3. Okay, so just a product like this. What we can do is multiply it out. Okay, you know how to do your FOIL and all that stuff. Okay, so if we multiply this out and keep track of all the powers of x, we're going to end up with x cubed. Okay, then we're going to have a plus b1 plus b2 plus b3 x squared. Okay, you can just check by multiplying that out. Then we're going to have a plus b1 b2 plus b1 b3 plus b2 b3 x cubed, x plus b1 times b2 times b3. Okay, so we've just grouped everything together so we can see the powers of x. So we've got x cubed, x squared, x, and x to the 0. Okay, so multiplying out the factors over there, very easy. Okay, so if I give you a bunch of products, you can multiply it out, quite straightforward. With factoring, we want to go the other way. So starting with some polynomial, which we can simplify in this case as something like a3x cubed plus a2x squared plus a1x plus a0. Starting from here, how do we go back to the products? So going the one way, very easy. Going the other way, not so much. Okay, I think the best way to learn this is just by practice. Okay, you do a bunch of problems, it will become easier over time. Okay, so let's have a look at some problems here. Yeah. Okay, I think everyone should be okay with factoring. Okay, so number one, let's say we have 2x cubed plus 5x squared minus 7x. So we've got a cubic polynomial. We want to go backwards to find the factors. Let's do it a bit at a time. So notice how all of them share a factor of x. The first term we could write as x times x squared. The second one is x times x, and the last one we just have an x. All of them have some x. So let's take that out. So x, what's left over? 2x squared, 5x, and just a 7. So by factoring out the x, we've reduced the cubic factoring to now a quadratic factoring, which is a bit easier. So we do it step by step. Okay, and now we need to factor this. Okay, I think everyone should be familiar with that. Everyone okay? Yep, okay. So we're going to end up with 2x plus 7 and x minus 1. Right, so again, just a recap, how do we get those numbers? Well, we look at the factors of 2 times 7, that's 14. Okay, so we multiply them, we get 14. We need the factors of 14 to give us a 5. What's that going to be? Everyone know how to do the factoring? Who doesn't? Hands up. Okay, so you're good. Okay, yeah, so we got those factors. Let's multiply it out just to check. 2x and x, that's the 2x squared. Then we have the minus 2x plus the 7x. So the 7 and the minus 2, that gives us the 5. Right? That's the factors from the 14, the 7 and the 2. So 7 minus the 2, that gives us the 5. And then how do we get 7? Well, that's just 7 and the 1. Okay. So here, there, and there. This is just the factors from 14, which was just the 2 and the 7. Okay. Okay. Everyone should be familiar with that. Okay, number 2. Let's say we have 3x squared plus 10x minus 8. Okay. So we look at the 3 and the 8, multiply them, we look at the factors that give us 10. So the sum or the difference of the factors must give us 10. What's that going to be? Yeah? Sorry? 2 and 8. Not quite. You're missing one. For the 2 brackets, right? We're looking for the numbers for the brackets. Okay, well the first one's quite easy. We want 3x squared. So if we're writing this in the the 2 brackets here, then we need a 3x, of course. And then we need an x. Okay, so what's left? I'm starting to think you don't know how to factor. Yes? 4 and 2, yeah. One of them must have a minus sign because of the minus 8. Which one has the minus sign? The 2, yeah. And then the plus 4. Okay. So the factors that give us 10, that will be the 12x minus 2. So it was 12 and 2. Okay. So not 8 and 2, it will be 12 and 2. Okay, so again, these factors come from the factors of 24. Right? The 3 and 8, that gives us 24. So 1 and 24, you check that. 2 and 12, you check that, and so on. 2 and 8, it does give us 10, but the product's not going to be 24. So we need the 12 and the 2. That gives us that. Okay. Any questions on that? Okay. In the tutorial, there's plenty more you can try out. Okay. There are some more homework problems here. I'll just add that to the tutorial list. Okay. But if you are having any issues, if you want to see me one-on-one, perfectly fine to help you out. Okay. Or you can send me an email. Okay. All that stuff is on the Learn page. All right. Any issues with polynomials before we move on? Okay, as long as you know what a polynomial is and how to factor quadratics, you should be fine. Okay, next, rational functions or expressions. Okay, again, if you don't stop me, we move on. Okay, it's up to you. Okay, please do not be shy to stop me. Right, everyone's here to learn. If we go at a slower pace because someone needs the help, that's fine. Okay, we've got plenty of time. Okay, rational functions or expressions, you might see it with those 2 different names, means the same thing. So a rational function or expression is a quotient of 2 polynomials. Okay, we know what polynomials are. Okay, so just some examples so we know what's going on. So let's say we have 6 over x minus 1 that is a rational function. The top is a polynomial. It's just a constant polynomial. We could have written this as x to the 0. Okay. 0th order polynomial is just another word for a constant. In the bottom, that is just x to the 1. Again, that's a polynomial. Okay, this next one is a bit more obvious. We've got x squared minus 1 over x squared plus 5. Quadratic polynomial at the top, quadratic polynomial at the bottom. Okay, that's a rational function. Okay, next one as well, quite obvious. So we have x to the 4 plus 18x plus 1 over x squared minus x minus 6. Okay, 4th order polynomial at the top, 2nd order polynomial at the bottom. Okay, it's a rational function. Okay, and then the last one, 4x squared plus 6x minus 10 over 1. Okay, we've got a polynomial at the top and a polynomial at the bottom. Remember, 1, we could just write as 1 x to the 0. It's a 0th order polynomial. So that last example tells us something quite interesting. The 1 in the bottom, we could just not write it. And what that means is that polynomials are also rational expressions. Okay. Because we just take a polynomial, we set that to be the numerator, the denominator we just call 1, and we've got ourselves a rational expression. So all polynomials are also rational expressions. This is a good true or false type question that may or may not come up in class test 1. Okay. All polynomials are rational expressions. Okay, in brackets, how? Well, the denominator we just set to 1. Okay, and 1, that's just a 0th order polynomial. Okay, so please just keep that in mind. If we are working with rational functions, polynomials are also included under that umbrella. Okay, any issues with the definition? All good. Okay. Just a little terminology. Okay, so a rational expression is in lowest terms okay, so just a definition for what lowest terms means. It's lowest terms when the numerator, okay, that's just some polynomial, and denominator share no common factors. Okay, how do we check this? Well, we've got a polynomial. We know how to factor the polynomial. That's for the numerator. For the denominator, it's a polynomial. We know how to factor the polynomial. We look at the top factors, we look at the bottom factors. If there's anything in common, then it is not in lowest terms. If there are no common factors, then it is in lowest terms. It's just a yes or a no, depending on if there are common factors or not. Okay, let's look at some examples. So let's say we've got x squared minus 2x minus 8 over x squared minus 9x plus 20. And the question is this in lowest terms? Again, it's a yes or no question. So how do we check? Well, does the top and the bottom share any factors? In this form, we can't really tell. we can't see what the factors are. So we factorize the top, we factorize the bottom, and we check. So here we factorize the top. Factors of 8, we need to end up with 2, so we better use 4 and 2. So that's going to be x minus 4, x plus 2. So the minus 4 and the 2, that gives us the minus 2x, and the product gives us the minus 8. Okay, so that's the top done. Now the bottom. So this is going to be x minus 5, x minus 4. So the minus 5 and the minus 4, that gives us the minus 9. We take the product, we get the 20. Okay, easy stuff. Now we check, top and the bottom. X minus 4 at the top, x minus 4 at the bottom. They do share common factors, so it is not in lowest terms. We can just get rid of those, top and the bottom. So here, this will be x plus 2 over x minus 5. This is now in lowest terms. So previous step, when we had all those factors, this is not in lowest terms. We can just cancel the factors, top and the bottom, and now it is in lowest terms. Okay, quite simple. This cancelling the factors, we will see quite a bit later on when we do functions. Okay, when we look at domains and ranges of functions, this will become quite important. Okay, number 2. I don't think we need to do too many. I think everyone gets the idea. So let's say we had x squared minus 25 over 5x minus x squared. Okay, again, in this form, we can't see what the factors are, so we don't know. Let's factorize the top and the bottom. X squared minus 25, that's x squared minus 5 squared. So x plus 5, x minus 5. Over, in the bottom, we've got an x and an x. We can take x out. So we're left with 5 minus x. Okay, it looks like we don't have any common factors. In the top, we've got x minus 5. In the bottom, we've got 5 minus x. They look different, but let's just take out a minus from the bottom. So this is going to be x plus 5, x minus 5, extra minus in the bottom, x minus 5. If we put the minus back, we would end up with 5 minus x, which is what we had. Okay, but now those are the same. X minus 5, x minus 5. So now we can cancel. Cancel, cancel. This is going to be x plus 5 polynomial at the top, and in the bottom, some other polynomial. Okay, again, minus x, that is a polynomial. It's just a first order polynomial. Okay, it doesn't have to be some cubic to be called a polynomial. X by itself, perfectly fine polynomial. Okay, any questions on this? All good. Okay. Last one I'll leave for homework. Okay, please start expecting this amount of work from now on. Okay, so the amount of work we've done in this lecture, next lecture, same thing. Next lecture, same thing for the rest of the year. Okay, university is not matric. Okay, a lot of work will be coming for you, and it will be coming quickly. Okay, please get used to it. Okay, number 3, x to the 7 plus 2x to the 6 plus x to the 5 over x cubed, x plus 1 to the 8. Okay, we have a polynomial at the top, we have a polynomial at the bottom. In the bottom, it's already been factored. We've got x cubed as one factor, x plus 1 as another factor to the 8. So the top we need to factor, the bottom is factored for you. Again, the question is this in lowest terms? Okay, we can't tell because the top isn't factored. Please factor the top, cancel anything, and then check. Okay, any questions about this homework? All good. Okay, the next one on inequalities, we will do that on Wednesday. so that's going to be it for today.